Welcome back to the tutorial course on Android app development. In this section, we will discuss the lifecycle of fragments. Let's start by reviewing the lifecycle of fragments. In one of the previous lectures, we briefly discussed an activity lifecycle. We also discussed the activity lifecycle methods, such as onCreate, onResume, and onPause. Let's now consider the skeleton of a fragment. Open Android Studio and navigate to Home Activity using the app. Go to Java. Click com.eduonics.training.weather app and select Settings Fragment. On the next slide, we will try to understand the lifecycle of fragments in detail. Let's first understand the lifecycle of a fragment, its importance, and the need. A fragment contains callback methods that are similar to the methods of an activity. Some of these callback methods are onCreate, onStart, onPause, and onStop. When converting an existing Android app to use fragments, we can move the code from the activity's callback method to the respective callback methods of the fragments. In addition, fragments contain their own lifecycle callback methods. One such example is the onCreateView method. The flowchart about the fragment lifecycle shows a similar structure of an activity lifecycle. However, a fragment contains more methods than an activity. We will discuss the most important callback methods, such as onCreate, onCreateView, and onPause. In the subsequent slides, we will discuss the various callback methods. The system calls the onCreate method when it creates a fragment. During the implementation, we should initialize essential components of the fragment that we want to retain when the fragment is paused or stopped, and then resumed. Let's override the onCreate method. Let's insert a logger to denote the invocation of the onCreate method using the following code. Now that we understand the onCreate method, let's learn the onCreateView method. The system calls the onCreateView method when the fragment draws the user interface for the first time. To draw a UI, we must return a view from this method, that is, the root of the fragment's layout. We can return null if the fragment does not provide a UI. We have already created the onCreateView method while drawing the UI inside the fragments in the previous class. Now let's insert a logger to inspect the invocation of the same. In the next slide, we will discuss the onPause method. The system calls the onPause method as the first indication that the user is leaving the fragment. However, its fragment is not always destroyed. This method is commonly used when we need to commit any changes that should last beyond the current user session. When we start to insert the onPause method, Android Studio will auto-complete it. Android Studio will insert super.onPause, which will further invoke the onPause method, which is its parents class. We need to insert another logger on the onPause method. Now we have set up the loggers and tests for the lifecycle of fragments. In the given image, we have used the onCreate, onCreateView, and onPause methods. In the next slide, we will try to run the app and observe the results. Now, let's run the app in the emulator to view the current state of development. When we launch Settings Fragments inside Weather app, we can see that the logger shows the onCreate and onCreateView methods in their respective order. Let's press the back button. We can see that onPause is invoked when we exit the fragment. The corresponding logs are displayed in the window. Considering the order in which each log is shown, it is evident how the life cycle of fragments operates. This brings us to the end of our discussion on the life cycle of fragments.